We're going to take a short break here from systems because we need to regroup and go back to graphing linear equations, because what we're going to transition is we're going to take them and make inequalities, and then we're going to go back to systems of inequalities. So the first thing we're going to do is we're going to revisit some of the basics of inequalities from much earlier in the year, because it'll help us as we then start to look at linear inequalities. So we're going to share a screen here with the doc cam. And we're going to go back to some notes from much earlier in the year. You do not have to write these down because you should already have them in your notes. We're just reviewing here because it'll help transition us into linear equations. All right, just want to make sure we were recording, and we are. Okay. So if we go back to our multi-step inequalities, we wanted to get the variable alone. We wanted to understand that there was not just one solution, but there's a set of solutions, because y is greater than something. So there's going to be this idea that there's more than one solution now, so there has to be a visual. Well, that visual is going to translate into what it is that we are doing with linear. If we go back to early in the year, the less than symbol meant open dot and arrow to the left. It didn't include the point, it was just everything smaller. Greater than was an open dot, everything to the right. Less than or greater than to equal had the closed dot because it now included the solution. And then we would go to the left or the right based on that. These ideas of including it or not including it, to the left or to the right, is going to now come into play when we do linear. So we're going to have to see how those ideas will now translate to a linear inequality. So here are your notes for linear inequalities. And these are notes that you will want to either write down or copy or print. If you can print, it would be really nice, because there's going to be grids that you're going to want for graphing. If not, you're going to have to sketch it. The first thing is you're going to graph using y equals mx plus b. So the shortcut for graphing is the same. And for the immediate, you're just going to ignore the inequality symbol and graph just as if it was y equals mx plus b. When you draw your line, if it's a less than or equal to or greater than or equal to, it's going to be a solid line. If you remember, we used to close the dot or have the open dot. Well, now what we're going to do is we're going to close the line, make it solid, or we're going to make a dotted line if it's the greater than or less than. Okay, so if it's equal to, it's a solid line. If it's only greater than or less than, it's a dotted line. And then we're going to shade above or below. And that's going to be the tricky part, is figuring out which side to shade. So the first thing I'm going to do is I'm going to look at this symbol and decide if it should be if it should be dotted or solid. And it should be dotted because it is not equal to. And then I need to go ahead and figure out how to graph it. So I'm going to use my shortcut for mx plus b. So my first point is going to be at -3 on the y-axis. I'm going to put a dot right there at -3 on the y-axis. The slope is 2 over 1. So from here, I'm going to rise 2, run 1. Rise 2, run 1. Now remember, when I draw this line, it is a dotted line because it was simply greater than. So I'm going to go ahead and draw the line. Now here's the issue. I screwed up. And I did this on purpose because I want you to understand what's going to happen. You're going to do this as well. And this is why if you use a marker or a pen, you are going to have a difficult time. Now the good news is on IXL, it fixes it for you. All right, so I'm going to go back over this and I'm going to draw on it, and you notice it does work. So if this is a test, I'm going to do this. I'm going to write dotted right there because I want to make sure that the teacher knows exactly what we're talking about. So let's go ahead and use the orange highlighter so I can make this dotted for you. Okay. Now the question is, which side am I going to shade? If you remember when we did the regular ones, it would be a line to the left or a line to the right because it included more. Well, when it's on the grid and it's in a linear inequality, we're going to shade on either side of the line. Now I'm going to give you two techniques to decide which side to shade. The first technique is the one that I think is the easier of the two, but that's because it makes sense for me. This right here says that y is greater than 2x minus 3. It's greater than the line. Well, if I look at the grid, where are my y values getting larger? Are they getting larger as I go up, or are they getting larger as I go down? Well, on the y-axis, my values get larger when I go up. So I will shade above the line. So I like to sort of pull up here to remind me that that's the shade, the side I'm shading. So I'm going to shade. I'm going to shade in the whole entire region. So the shaded area, every single point in the shaded area is part of the solution. And the reason why it's part of the solution is because if I plug that ordered pair in, it's going to make a true statement. And that's the second way in which you can decide which portion to shade. I'm going to pick the point right here, 0, 3. It is very distinctly in the shaded area. If it's in the shaded area, it should work. So I'm going to take 0, 3, and I'm going to plug it into the inequality. So the x value is 0 and the y value is 3. So I get 3 is greater than 2 times 0 minus 3. So I took the x and the y value and I plugged in. 3 is greater than 0 minus 3. Is that true? Is 3 greater than 0 minus 3? And the answer to that question is yes, it is. What that means is 0, 3 is a solution. So if you want to try and figure out which side to shade, pick a point in that portion of the graph, and if it makes a true statement, then you shade that side. If it makes a false statement, then you know that you picked the wrong side. So let me show you. I'll pick this point right here, clearly in the unshaded area, so it should fail. So we're going to try 6, 0, and we'll plug it into this inequality. So that gives me 0 is greater than 2 times 6 minus 3. 0 is greater than 12 minus 3. Clearly, that's not true, and that's not supposed to be true because it's in the area that's not shaded. So 1/2 of the line, every point in that area is going to work. The other half, they're not going to work. So you can shade it based on y is greater than or y is less than, or you can test a point and see if it works. Okay. So let's look at another example here and see what happens. So here is my inequality. It is in mx plus b, so we're in good shape. Y is less than or equal to negative 3x plus 5. Well, less than or equal means it's going to be a solid line, and I'm going to use the mx plus b shortcut. So I'll start at plus 5, and my slope is negative 3 over 1, so it's down 3, 1, 2, 3 over 1. Down 3, 1, 2, 3 over 1. And remember, solid lines. So I'm going to plan ahead. I'm going to remember what I'm supposed to do. And I'm going to go ahead and put in my solid line. Now I'm going to have to shade one side of it. So you've got two options. You can pick a point, test it, and see if it works. If it works, you shade that area. If it doesn't work, you shade the other side. Or you can look at the letter Y. Now, I'm going to go ahead and start simply by picking a point. So let's pick an easy one right here. Let's pick the origin. Let's pick 0, 0. So let's test 0, 0. If it makes a true statement, I'm shading the side of the line with 0, 0. If it makes a false statement, I'm shading the other side. So this is going to say 0 is less than or equal to -3 times 0 plus 5. So I plugged in the 0 for the x and the y. 0 is less than or equal to 0 plus 5. Is 0 less than or equal to 0 plus 5? And the answer is yes, because it is less than. That means this point worked. That means I have to shade the side of this line that includes that point. So that means I'm shading that side of the line because that's where 0, 0 was located. And if we think about it, y is less than or equal to this. So where are all the y values less or smaller? As I go down. So you'll notice everything below the line on this one. So you can go above or below the line, or you can pick a point to test it. Well, let's go ahead and throw one more at you that's going to be a little bit trickier, only because you got to remember the shortcut. X is greater than -4. What kind of line does x equals make? And you should have memorized this from second quarter. X equals is going to make a vertical line. So that vertical line is going to be at -4, and it's going to be a dotted line. So I'm going to make a dotted line right here at -4. And now this one, I could go ahead and pick a point, but the real way is to just look at the x and say, okay, what do we know about x? It wants all of the x values that are larger, bigger than -4. Well, where are those? Those are all to the right, because that's everything on the x-axis that is bigger than -4. So I'm going to shade this whole side that is to the right of that dotted line. Anything on that side is a solution. Okay. So graphing linear inequalities is going to require solid versus dotted line. And then you're going to have to shade one of the regions based on whether it's greater than or less than. Okay. So let's take a look at the IXL. Let's see what this section is going to look like when we have to do it on the computer, because this is where you're going to have to really understand the interface of IXL. So let's go ahead and share our screen here for IXL. So for linear inequalities, here's linear functions. Linear inequalities is the letter T. There's two sections. Does x and y satisfy the inequality? So you are simply going to look at this, and you're going to plug in the x and the y into the equation, and it either works or it doesn't. So you'll say yes or no. All right, so that was how we were checking a point on the graph. All right, but let's go to the actual graphing portion. So graph a two-variable linear inequality. You're going to have to remember, and you're going to have to use the sort of the IXL workings here. So let's look at an example here. Graph this inequality. Y is less than or equal to 6. Well, this is a y equals, so this is a horizontal line at 6. It's less than or equal to, so it's going to be solid. So we put our first dot at 6, and then I'm going to put a second one there. Now it starts to make the line. Now when I click another point, and it can be anywhere here, it's going to draw the line. Now the line is currently solid. If you go off to the side, you'll see it lets you then click again to make it dotted or make it solid. So you can go back and forth depending on what you need. Now I need it to be solid because it's equal to. Now y is less than or equal to 6. So now you'll notice it says, do you want to shade this side or this side? Well, the y values that are smaller would be this side. So I'm going to have a solid line, and then I shade below. Now, the nice part with IXL is you're not going to have to draw it. You're not going to have out your markers and do whatever you need to do. So I'm going to submit that, and good work. X is greater than or equal to 5. Well, here's a vertical line at 5. So I draw it. solid or dotted, it needs to be solid, and x is greater than. Well, our x value is greater to the left or to the right, and it's to the right, so we graph it. Okay. Y is less than negative 4x. So here's a linear one that's going to go diagonal. There is no y-intercept at the end, so my first point is at 0. My slope is negative 4 over 1, so I'm going to go down 4, 1, 2, 3, 4 over 1. And I draw the line. Now, do I want it to be solid or dotted? Well, y is less than, so I'm going to go back to this and click it again so that it is dotted. And now I have to decide which side to shade. And this is where you either pick a point and test it, or you understand that because y is less than, you already know which side to shade. Well, where are y values less? And that would be as I go down. So from the line below it, that's the area to shade. All right, let's see if we can kick it up here a level. There we go. Let's do one here. Y is greater than 3x plus 6. So my y-intercept is 6. And then my slope is up 3 over 1. I need a dotted line. And I need y values that are larger, which is above. So I shade right here above the line. And there you go. So that's taking your linear inequalities, learning how to graph them, and then learning how to put it on IXL.